Hi, my name is Carlin Bratcher, and today I'm going to be talking about the fuel system and proper operations. The objective is to learn the basics of fuel systems and their operations. The two common classifications of fuel systems in small planes are gravity feed and fuel pump systems. The gravity feed uses the gravity to transfer fuel from the tank to the engine and are common in high-wing planes. The fuel pump system uses electric and engine-driven fuel pumps to transfer the fuel from the tank to the engine and are common in low-wing planes. And this is a map of the gravity fuel system and fuel pump system. The tanks are at the top in the high-wing plane and basically let gravity work for itself and come down. In the low-wing plane, the fuel tanks are at the bottom and is being used by the engine-driven and is getting pulled up. Fuel tanks. The Cessna Skycatcher and Skyhawk have two fuel tanks, one in each wing, designed to allow airflow in the tanks as fuel is flowing to the engine. The bottom of the left wing has another fuel vent. It's a L-shaped tube. In flight, air enters the tube, helping keep positive pressure in the tank. Also, to keep the pressure equal, the two tanks are connected via vent line. Also, in warm weather, the fuel expands as temperature rises. If the tank is full, the fuel will come out of the L-shaped vent. Fuel strainers. Under each wing there are 5 drain valves, also called sump drains, located at the lowest point in the fuel tanks. Under the engine belly there is a fuel strainer that removes moisture and other sediments that may be in the system, and they should be drained before every flight. When checking for fuel samples, you are looking for blue color. You want to check for the smell, water-free, and free of dirt and contamination. Fuel selector. Fuel flows by gravity from the wings to the selector valve, which has 3 positions on the Skyhawk: left, right, and both. The valve is set by the pilot inside the cockpit. To allow selection of fuel from either side of the tank or both, the selector valve is set to both positions for most operations. Fuel consumption should be monitored closely to ensure that the tank does not completely run out of fuel if you have a single tank selected. Also, to ensure the fuel in the tank does not become unbalanced. This is a picture of what the fuel selector valve looks like in the cockpit. You have left, right, and both, which is what you want to have it set to. The fuel pumps can be engine-driven or electrically driven. The engine-driven fuel pump operates when the engine is running. You can detect the engine-driven fuel failure by a sudden reduction in fuel flow just prior to a loss of power. If the engine fuel pump turns on, if you have an engine pump fail, turn on the auxiliary electric fuel pump. An auxiliary fuel pump is used for starting engine to purge fuel vapor for fuel injection line and emergencies in the event of failure of engine-driven pump. The auxiliary electric fuel pump switch in your Skyhawk is a combined on-off switch and circuit breaker. When turned on, you will hear it running. The fuel shuttle valve. The fuel shuttle valve can be used by the pilot to cut the flow of fuel to the engine in emergencies. It's operated by pulling out the labeled red knob inside the cockpit. Pulling out on the red knob will stop the flow of fuel to the engine. Make sure the fuel shuttle valve red knob is pushed fully in before you take off. And this is a picture of the fuel shuttle valve, and you want to make sure that it's pushed in before you take off. Fuel quantity. Fuel gauges are only required to read accurate at 0 when the tanks are empty. You will always want to visually verify the fuel by checking the level inside the tank for a full or known reduced load using bottom of the Skyhawk filler tab, holes in the Skycatcher filler indicator tab, a dipstick calibrated for make and model. If there is a total electric failure, alternator and batteries, in an airplane with glass cockpit, the screens will go blank, making it impossible to read the fuel gauges. In an airplane with standard electrically operated gauges, the fuel gauges will go to 0, even if there is a fuel in the tank. In a Skycatcher with fuel sight gauges in the cockpit, you will still have an accurate fuel quantity indication without electric power. Fuel system closing. Remember to always be aware of how your system works in case of failure, so you'll know how to recover. Check vents for clogs. Make sure you have clean, quality fuel. And last, make sure you have fuel quantity and is accurate. Thank you and fly safe.